Okay, this is section 1.1, Analyzing Categorical Data, video B. We're going to pick up where we left off on video A. We had just gotten finished talking about how variables can be one of two types. They can either be categorical in nature. We said that is typically not numerical, but it can be numerical as long as averaging it would not make sense. Okay. And the other type of variable is a quantitative variable, and those are definitely numerical, and averaging them would make sense. Okay, we're going to focus in this video on analyzing categorical data. Okay, so again, categorical variables. Categorical variables. Typically place individuals into one of several groups or categories, okay? So we're going to talk about a few different ways that you could take data that is categorical in nature and analyze it, because we certainly can't find the mean, find the standard deviation if we're talking about categories. So you can do a lot more with quantitative variables when you're analyzing them. Mostly with categorical variables, you're just trying to come up with different ways to display the data. Okay, remember in the last video we talked about distributions. Distributions are what are the values that the variable takes on, and how frequently do they take on those values. And so one particular table that we use to display categorical variables is we use something called a frequency table. Okay, a frequency table. Okay, and what a frequency table is it lists what the variable is on the left side here, okay? And then it lists the count on the right side, okay? So you can see in this particular example, we have the format of a radio station, okay? The format would be our variable, okay? And then we have all of these are the different types of formats. So it looks like we've got 2, 4, 6, 8, 10 different formats here. Okay, and then along the right side, we're listing the counts, like how many stations have that type of format. Okay, so you can see there is 1,556 stations that have an adult contemporary music format here. Okay, and then all the way at the bottom, we would at least total those counts here. Okay, so the key here is that a frequency table, if I can highlight this any better, a frequency table is all about counts. Okay, that's what you want to kind of connect. A frequency table is all about counts. Okay, whereas the term relative frequency table is something different, okay? A relative frequency table, you'll notice, is still listing the variable here. It's still listing the different types of formats here. But what is different is instead of counts in the second column, these are the percents, okay? The percentages. So when we say that 11.2% of the radio stations were adult contemporary, we're getting that number, just to illustrate this, by taking the count from the other column here, this 1,556. We would divide that by the total over here, the 13,838, and that produces 11.2%. I mean, technically it would come out like this, and I think it's been rounded here, but then we know as a percentage that's 11.2%. Okay, so huge difference when you have the word relative here. That is talking about percents. Okay, two different ways that you can organize categorical variables. Okay. okay? Now, sometimes it's easier to analyze a distribution by displaying it with either a bar graph, okay, or what is known as a pie chart, okay? Now, there are a few things that you do need to be aware of or kind of watch out for with both bar graphs and pie charts. Okay, you can see there's a couple examples listed here. Okay, we're still using the same data from above where we're talking about the stations here. One thing that I will tell you in statistics, and they didn't do this here, at least with the bar graph, and that's not good, is anytime you are making graphs, particularly when you have an x-axis and a y-axis, you need to label what each of those things are describing. So for example, what each of these words, adult contemporary, adult standards, those are representing the format that should have been labeled down here. On an AP test, anytime you make a graph, a scatter plot, a bar graph, a dot plot, your axes need to be labeled. Okay, and then I'm going to go ahead and just label that these are referring to the counts. Okay, these are not the percentages. You can see that here, the count, and I'm just going to scroll back up to our frequency table. The count for adult contemporary was 1,556. We can clearly see here that this bar is roughly going up to that same amount here. Okay. Over here with pie charts, it's a little easier to kind of reference a relative frequency histogram. Okay, remember again, those are dealing with percentages. And the one thing that I will tell you is with the pie chart, you need to make sure that all of your percentages are certainly adding up to 100%. Okay, so two things just to kind of be aware of. With the pie chart, you must include all the categories that make up the whole, and by whole I mean 100%, okay? You could not just make this pie graph with, say, just these first 4 formats for radio stations, because that's not going to consume a whole circle, and it needs to be 100% here. Okay. The thing that I'll caution you of with bar graphs is the bars need to be made equal widths and start the scale at 0. Okay, start the scale at 0. By the way, a bar graph is when there are gaps in between the bars. You can see that here. Histograms are when these bars are pushed up against each other and there is no gap in between. Okay? All right, let's go ahead and go to the next page here. Bar graphs are used to compare several quantities by comparing the heights of bars that represent those quantities. And we saw that in the bar graph on the previous page. Okay? But our eyes, however, they kind of react to the area of the bars as well as the height, okay? So here is a huge thing that you need to make sure you're very, very cautious of. 1, when you're making a bar graph, or 2, when you're just looking at someone else's bar graph. When you're drawing a bar graph, you need to make sure that those bars are equally wide, okay? And so here's an example below here that we'll go ahead and kind of write down these 2 things, these 2 important lessons we want to keep in mind. You really need to be wary or beware of what are called pictographs, okay? Pictographs are when they use images for the bars, okay? So they use some type of a picture instead of just like a rectangular bar, okay? And the other thing we need to watch out for, and I'll explain why these 2 things are bad here. We need to watch the scales, okay? The scale may not start at 0, okay? And that could be displaying the information in kind of a wrong way if you're not watching for that. So it says here, what's wrong with the following graph, okay? So it says DirecTV stomps the competition. It says 95 have the favorite HD channels. 81 is Dish Network and 56 channels on cable, okay? The issue is, this picture right here is taking up a lot of space, 95. Okay, see how this is 81? This is what we mean by reacting to the area. It really makes it seem like this is a lot larger than Dish Network. Okay, so what's wrong is that the bars, okay, if you're going to treat these as being bars here, the bars widths vary. Okay, they're not the same width. Okay, and then also a scale is not defined. Okay, they're not defining a scale on this either. Okay, so what's the difference between a data table, a frequency table, and a relative frequency table? Okay, well, a data table, it just lists the data, okay? So it's simply just listing the data. So if you went and you surveyed, again, 50 Dover High School students and you asked them what their GPA was, a data table might just be, GPAs listed down. It's just the list of data only, okay? A frequency table, however, okay, and that's what we did on the previous page, this organizes by count, okay? So the key here is frequency table, that's a count, whereas a relative frequency table organizes by the percent of the total, okay? So the connection here is relative frequency table, that is a percent. Okay. Now, what is the most important thing to remember anytime you are making a pie chart or a bar graph? And that is on the AP exam, proper labeling. Okay. And we'll go as far to say anytime you make any graph, it doesn't have to just be a pie chart or a bar graph, you have to have proper labeling. Okay, and I will say, though, that between the two, bar graphs are often easier to make than a pie chart, and they're easier to compare visually. Okay, so you don't see a lot with pie charts on the AP test per se. Okay, bar graphs are used more than pie charts. Okay. All right, question 4 here says, when is it inappropriate to use a pie chart? Okay, this would be, I would say, if data comes from, different variables. So I shouldn't be combining two different types of variables and putting like percentages for two different types of variables. If you remember back before, I think they surveyed like maybe 10 random U.S. citizens from the census, and there were all sorts of different variables. Where do you live? What state? What's your gender? What's your age? You would not want in one pie chart to like be combining the percentages of different variables. And then the other thing that would be inappropriate is not including all or 100% of the data. Okay, it needs to be 100% of the data so it can take up the whole circle there. Okay, and then finally, what are some common ways to make a misleading graph? Okay, one of those would be maybe that your scale doesn't start at 0. Could be using inconsistent bar widths. And we really just want to altogether, I won't say it that way. I'll just say using pictographs. Okay, the pictographs are not a good idea. Okay, so you can see here, here's a homework assignment that ties together both 1.1 video A and 1.1 video B. Okay, those are problems that at this point you should and need to do.